Hi, this is Alex from devstories.eu. DeepEval Framework, Episode 5 of 18. If your LLM is giving bad answers, it might not be the model's fault. Your retriever might just be feeding it garbage. Today, we are talking about evaluating RAG retrievers, specifically using contextual precision, contextual recall, and contextual relevancy. Think about querying a large knowledge base for a very specific policy detail. Instead of extracting the one exact paragraph you actually need, your retriever grabs 10 pages of loosely related text. The LLM gets lost in the noise, token costs go up, and the final answer suffers. To fix this, you have to measure the retrieval step entirely separate from the generation step. The first measurement is contextual relevancy. This metric looks at the raw chunks of text your retriever pulls from the database and calculates the ratio of relevant sentences to total sentences. If you retrieve 1,000 words just to capture one useful sentence, your relevancy score crashes. High relevancy means you are passing a clean, dense context to the LLM prompt without wasting tokens on irrelevant background information. Next is contextual recall. This evaluates whether your retriever found all the necessary information required to answer the user's query. DeepEval calculates this by taking the expected output for a query and extracting all the factual claims from it. It then scans your retrieved context to see if those specific claims are actually present. If a crucial fact needed for the answer is missing from the context, the recall score drops. High recall guarantees the LLM actually has the raw material it needs to succeed. Then we have contextual precision. People frequently confuse precision with recall. Recall means you missed nothing. Precision means you included no fluff. In RAG evaluations, precision heavily factors in ranking. It checks if the highly relevant chunks of context appear at the very top of the retrieved list. If the one vital paragraph is buried at position number 10 beneath 9 useless chunks, your precision score is low. Language models generally pay more attention to the top of the prompt, so the order of retrieval completely changes the outcome. Here's the key insight. There's a constant tension between precision and recall. If you configure your retriever to return 50 chunks every time, your recall will probably be perfect because you cast a massive net, but your precision and relevancy will plummet because most of those 50 chunks are noise. Conversely, if you restrict the retriever to exactly one chunk, your relevancy is pristine, but your recall fails the moment a user query requires synthesizing two different facts from two different documents. To run these tests in the framework, you define a test case object. This object holds the user input, the expected output, and a list of the actual context strings your retriever fetched from the database. You instantiate the specific metric you want, such as a contextual recall metric, and pass it the test case. The framework then uses an evaluation model under the hood to read the strings, map the claims, calculate a penalty for missing or poorly ranked information, and return a final numerical score between 0 and 1. Evaluating your retriever forces you to confront exactly what you are handing to your generation model. A high-performing RAG pipeline doesn't just shovel data at an LLM, it filters and ranks that data ruthlessly. Thanks for listening. Happy coding, everyone.